For example, if I have x squared times x to the 11th, that is the same as x times x, because that's what x squared is, times x 4, 5, 6, 7, 8, 9, 10, 11. So if I count up how many x's I have, that gives me x to the 13th. And I already showed you why it works, because really x squared is just x times x, and x to the 11th power would be x times itself 11 times. So if I multiply all of those together, now I have x times itself 13 times. So I just took my 2 plus my 11 power. So to evaluate that, you actually have to multiply 3 by itself 5 times. So 3 times 3 is 9, times 3 times 3 is 9 more, times 3. You get 243. So 3 to the 5th power is equal to 243. 2 to the 3rd power squared. So what this really means is on the inside of my parentheses, I have 2 times 2 times 2, because I'm taking 2 and multiplying it by itself 3 times. And then I'm going to square that, which means that I have to do 2 times 2 times 2 times itself, 2 times 2 times 2. And when you simplify this or evaluate it, 2 times 2 is 4, times 2 is 8. So 8 times 8, which is 64. Now, if you notice, 2 cubed gives me 3 2's, and I have that 2 times. So if we have a power of a power, what you do is you take the exponents and you multiply them, 2 to the 6th. So if I have x to the 3rd, y to the 4th, and I'm raising that to the 5th power, you have to multiply the exponents of everything. So this is the same as x to the 15th and y to the 20th. And I can show you why. So x cubed, once again, is x times x times x. And y to the 4th is y 2, 3, 4. So I have this 5 times. So that is why you multiply the exponents. So if you want to write this down, when you raise a power to a power, you multiply the exponents. Well, x to the 6th divided by x squared. What we're going to do is we're going to rewrite this so that you can understand why it makes sense, and then you'll write the rule down. So x to the 6th is x times x times x times x times x times x. Divided by x squared is x times x. Now, because we are multiplying everything, we can do some canceling, because I'm multiplying everything on top and everything on bottom. And we're multiplying everything that has the same base. So if I have x on top and x on bottom, x divided by x is 1, so they cancel out. And here I have x divided by x is 1, so that cancels out, which leaves me with x to the 4th in my numerator. So let's do an example of it flipped. So if I had x squared divided by x to the 6th, that would be the same as x times 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 x, right? 6 x's. So once again, those still cancel out, which leaves me with a 1 on the top and x to the 4th on the bottom. So if you noticed, when we have these exponents, I take the exponents from the top and I subtract the exponents from the bottom, and that will give me my final answer. So another way that you could write this is also x to the negative 4th, but in a video just a little bit down the ways, you're going to find out why when we rewrite x to the negative 4 as 1 over x to the 4th, A, that they are equivalent, and B, we typically like to take negative exponents and make them positive. There's always a party with the bigger number. So up here, there's a party because there's 6 people. These two people in the basement, they don't want to hang out there. So so you always start subtracting kind of by where the bigger number is. So 6 minus 2 gives me x to the fourth. Now here, you would do the same thing, but the party's in the basement. There's more people down there. So when you subtract, you do 6 minus 2, and you get 4, but the party stays in the basement. Well, whenever I divide a number by itself, that is equal to 1, which is why it always cancels out, because when you multiply 1 by anything, you just get 1. So 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So when I multiply this all together, I get 1. Good luck.
Is that when you have a base raised to a negative exponent, that is simply going to be equal to 1 over that base raised to the positive exponent. And the contrary is, if you have a negative exponent on your denominator, we can make that positive by writing it now as a positive exponent or a positive power in the numerator. Because let's take a look at it. If I was going to follow the quotient rule, that would be what? 3 to the first minus 3. Right? If you were to apply the quotient rule, Ashley, if you were to apply the quotient rule, you would take 3, the top numerator, which is this power, and you'd subtract it from the degree or the power in the denominator. So 1 minus 3, right? But if now when we follow our negative exponent rule, when you have 3 to the negative 2, we write that as 1 over 3 squared. So do you guys see how if I write it out, I get 1 over 3 squared. If I follow the quotient property, I get a 3 to the negative squared. And then I apply the negative exponent rule, and I rewrite that as 1 over 3 squared, which, like Mendoka wanted to simplify to, we can just simply write as 1 over 9. All right? But all I want you guys to understand is when you have a negative exponent, you have to make sure that if the negative exponent's in the numerator, you write it down in your denominator, and you can create it, and you can show it as positive. And then Sadiq, the other way is if you have it in your denominator, you can write it back up as your numerator.
That the square root of 81 is 9. And over here, what I'm really asking myself is what times itself is equal to x to the fourth. So I hope that you know that x squared times x squared equals x to the fourth. Since there are 2 of them, they no longer need to be underneath the square root. So we can take it out, and our final answer is 9x squared.